Hi, I'm Paqueta12 and today I will show you some of my methods of dealing with noise. But first, let's go back in a previous tutorial where I had Stas showing me resample SOP right here. Thank you so much, Stas. And let's recreate the situation we had. So we have a polygon made out of circle SOP with 5 corners, right? So now if we use resample, okay, and let's see the points, okay, and resample by polygon edge. Now if you modify this length here, you'll get a nice ordered array of numbers. So it's very nice operator, this one. But if you like the method in tops, then I will show you the fastest one. Okay, so let's say we have 2 points, so we use noise for that, and we go for 2 by 1 resolution, nearest pixel 32, and color. Let's make it a little bit bigger, like this, and we put a null. Okay, so first let's see those points. So null here, and tx, ty, tz. We don't need alpha for now. Okay, and we take a sphere SOP, and the radius is 0.5, 0.5, 0.5. Okay, and now we use transform. Okay, 1 divided by 64, I guess it's good. And now we need a geometry comp. Okay, and if we take these points now, let's split the window like this, and geometry viewer. Okay, now we have these points, and if we go for textures and keep the points, obviously when we resample somehow, we need to change that amount of pixels in our resolution. So let's try resolution. Okay, and first let's have here constant and lerp. Okay, and I want 16 points, and here we'll resize the input noise with this amount. Okay, obviously we have some points here, but a lot less than 16. So let's set the aspect and resolution, and here we choose nearest pixels. Okay, not in the input smoothness. Okay, look, so here we leave it interpolated pixels. Okay, now we noticed the points in the beginning and at the end, they might be similar. So the trick with this method is to resize these textures by double of this amount, and then group by half of these numbers. So here we say divided by 2, and here it's multiply by 2 minus divided by 2. Okay, now we wrong here. Now we good. And now we have 16 points right here. And yeah, this is a much faster method, right? But now we'll go back at noise stop. So this little fellow here, and I would like to have a resolution for this texture. So I can use the same constant and pick a resolution 1 to 8 would be nice. Okay, we don't actually need this for now. Okay, and we take this resolution and use it for our noise. 32 bits color, and yeah, let's see how it looks if we want to see the points. So because we already have something like this here, we just take it and duplicate, and we say this top two will take this null, and we only need because now we have only one row of this texture, right? And we need to say full image here, and right after a shuffle, and sequence channels by name. Okay, now we have our noise. Let's play a little bit here and scale it a little. Okay, and increase the period. Okay, let's make it move by translating the z-axis. So abs time. Now abs time dot seconds. Okay, divided by 20. Okay, now the majority of points here are in the area between 0 and 1, and we can see this by using a box SOP and the material SOP and a constant. Okay, and for the constant we go for wire, and yes, let's see this cube, and we need to translate the cube in the 0, 1 area, so we'll do that by changing the center 0.5. Okay, so obviously we can use a translate to center operator here at the end, and we use math. Okay, and we say range from 0.1 to minus 0.5, 0.5. This is one option to center the noise. Okay, the other one is change the offset here to 0. Okay, anyway, we want to have the noise and all the textures values kind of between 0 and 1, and only in the end we translate it to center. Okay, so we put this back, right, and use this mod. Okay, now you notice if I pause here on minus z axis, some points are going out of the square, and I would like to not have that. Okay, and there are several solutions for that, and the easiest one is just level, right? If I use level here, now there is not a single point going out of this box. What's happened if we take out this math? So anyway, the alpha is not okay, and put the box into 0, 1 area. Okay, look here. What level does, actually this clamp here will stop any value bigger than 1, or any value smaller than 0 will stop them. And yeah, this is one way of putting the dots inside the box. Okay, let's go back and center everything. Okay, and yeah, I can make this a folder and say clamp. Okay, now what if I want to have a kind of a bouncing spheres when they reach the walls of a cube? And actually it's a fake bounce, it's a mirroring position, and we'll do this right now. First we put a null here and select, click outside, collapse selected, and we have another folder, and we say bounce. Okay, and go inside, and now for the bounce we need two constants. So constant 1, okay, is let's split top bottom and take this resolution. Okay, we don't need this. Good. So one constant, it's 0 and it's 32 bits, and the other one it's 1. Okay, so this is 0, 1, and now we use difference top. Okay, and another one here, and now we have our noise mirroring the outside points inside. So yeah, it looks like bouncing a little bit, right? Okay, this is the second type of arranging noise. And now what if I want these noisy points to always reach the faces of a cube? Actually, I'm talking about normalizing the values So I will always have 0 and 1, and yeah, let's do that. So let's put a null here. Okay, click outside, collapse selected, and here we say normalize. Okay, we go inside, and what we need to do is normalize the values on all three axes. So for that I will use 3 reorder tops. Okay, first one will take red, and I will mark with red color. The second one will take green, I will mark it with green, and the last one will take blue. Okay, and all of them are 32 mono. Okay, so now I want to find out the minimum and maximum here, and then rescale everything to 0, 1. So for that I use analyze top. Okay, this one is for minim, so it's min x. This one is maxim, and it's max x. Okay, no, sorry. Okay, and I will use top to chop to take the red channel out, and I'll name it min x in this case. And this one max x. Okay, now if I use a math here, and I will say, okay, I want the range from this minim to this max to 0, 1. Now I have the points coordinates, x coordinates normalized. So we need to make the same for all 3 channels. So okay, and this one is y, okay, okay, and now this min, this max. Okay, last one. Okay, so this one is z, okay, this one and this one. Okay, we're almost there. Good. And now I want to make a RGB texture with this value. So I use a reorder top, and I connect all 3 textures and say red it's input 1, input 2 it's green, input 3 it's blue, and yeah, let's set alpha 1. Okay, and this should be 32 RGBA. Okay, and now I connect here, and you notice now my noise always touch the faces of the cube no matter what. Oh, here it's going mad because okay, now we good. Okay, and yeah, I know, let's make a texture for the color and try to so we need a noise. Okay, this resolution, we put a null here, and we'll take RGB out. So RGB, not caps, RGB. Okay, and here we use merge, chop, and now we have some colors. Let's see, RGB. Okay, so but this has to be 32 and color, and okay, so now we have colors. What else we can do here, you know, is always my favorite. We can use pixelate. Okay, and what this does, let's see, so what pixelate does is making those clusters, right? And if I don't know, let's say we have 1 to 8 resolution, so horizontal pixel size is 1 to 8, and this is 1. We have something like a snake. Okay, and if we divide this by 3, then we have 3 snakes. Okay, so what time we have? Okay, I will show you one more thing, and is how to put those points. So let's get rid of the pixelate, right? Okay, how to put those points on a sphere. So let's do that. We use a null here, and collapse selected. Oh no, okay. Oh no, it's something strange. I did completely wrong. Okay, no, and we name this sphere. Okay, let's go inside and see what should we do here. Okay, so imagine, let's have a sphere right here to see. So sphere 0.5, 0.5, 0.5. I want the same material. Okay. Now let's pause here. So let's say I would like those points outside the sphere to remain on a sphere surface. Okay. And for that we need a radius for a sphere, and we good to go. So let's suppose that the sphere is one diameter, so radius is 0.5. Okay, and go inside here. I want to find out the distance from each point to the center and form a fraction with the radius divided by distance, and then multiply this with x, y, z coordinates. Hopefully we'll get the desired result. Let's see. So first let's use a constant. Okay, so this resolution. Okay, and we name it center. Okay, and this center is 0, 0, 0 and 32. Okay, and now we use subtract. Yes. Okay, and here we use math for Pythagoras. So in this math we say square add root. We don't need alpha here, and all of this is 32 mono. Okay, so this is the distances. Okay, now we need a constant for the radius. So, and this radius is mono, right? And the value here is this one. Okay, and now we say radius divided. No, we don't have divide here, but we use composite, and here is divide. Okay, now let's multiply those points with this fraction. So let's say multiply. No, not good yet. Oh, and this is because we are in the area here where the middle is not 0, actually it's 0.5. So I use 0 for the center, okay, which is not good. So the center is 0.5, 0.5. Okay. And this is good. Radius. Just wait a second. Okay, so we need to use this translation to center before, right? Now we have our noise only moving on a sphere surface. Okay, let's check. Let's use like this. Okay, we don't need math. We go from minus 0.5 to 0.5 from the beginning. Okay. Okay, this is how you force a noise points onto a sphere. And let me take this off. You see? And what if we want to keep the inside points how they were before? And for that we go here and said, okay, so let's compare the radius and the distance. And we do that by make radius and use subtract, and like that. And then we use math and ceiling, right? And the white points are inside, the black points are outside, or opposite. Okay, that doesn't matter right now, because we use level here and get the inverse of this texture, right, with the invert. Okay, and now we need to multiply this with okay, so multiply this one here and multiply like this, and now we add those. I hope it's not bad. Let's see. Okay, now everything outside the sphere, it stays where it was. Okay, and I will show you from where you can switch that. Right here in subtract, if we inverse those like this, now we have all the points inside the sphere. Okay, and yeah, you can now you can try this pixelate, and I don't know, play with this, or you can chain those and yeah, see what you got. Okay, this was my tutorial. I hope you like it, and yeah, subscribe to my channel. The next one will be here in short. Bye.